Assalamu alaikum and good morning everyone. I am Ahmed M. Ismail and today I'll be explaining the practical we have done this week, which is practical 9 with my group 4. So first, for the introduction, this is a course of Chemical Engineering Laboratory 1, ECH 3908. The practical we did, which is practical 9, which is operation of heating and cooling system under the instructor Dr. Faiza. Our group members are me, Ahmed Ismail, metric number 231149, Noor Liana Balqis bint Mohammed Raizal, metric number 228843, and Mohammed Faris Zikri, metric number 230355, and Haris Alam Basayid, 226594. Yeah. For the learning outcomes for our practical, first we have to understand the thermal and the humidity dynamics in heating, cooling, humidifying, and dehumidifying, which we have done throughout this experiment, and you're going to see more details as the presentation goes on. Then for the final thing in my part, the experimental steps. First, you need to conduct 4 parts: heating, cooling, humidifying, and dehumidifying, which we've done by heating the insulated box using the heater for 15 minutes, and we recorded the temperature for every 3 minutes, like in 3 minutes intervals. And for the cooling, we just turned off the heater. And then for the humidifying, we just used the water spray or the humidifier to add some water. And same, we recorded the humidity in 3 minutes intervals until 15 minutes, and then the same thing with the dehumidifying. And yeah, that's it. And that's it from me. Thank you. Okay, so for the apparatus, we've used these instruments, like you can see in the picture, the insulated box and the heating element, which is the white thing there, and also the cooling fan, which is attached to the insulated box here, and the hygrometer, which is also inside the thermometer as well. This black square thing is a thermometer and the hygrometer as well. And then for other tools we used a humidifier or water spray, whatever, and we used a stopwatch where we used our phones as stopwatches.
Okay, so here is our drawing. So in here you can see on our front we have our cooling fan, which will be used during cooling and also humidification. And then on the right side you can see that we have one sensor here, which we put the sensor in the box at the bottom, at the top. And then on the right side we have another tool, which the first one we put on the middle of the box, and on the back we put at the bottom, at the bottom of the box. So should be inside the box. We should put it here, inside here. As you can see here, we should put our heater, which will be on during heating and will be closed for the rest of it after the heating process. And then we also have our box head, which will be closed most of the time and only will be open during when we want to put our air humidifier, just like a few seconds, and then we close. So this is our drawing for experiment 9 using AutoCAD. Okay, so here is our AutoCAD drawing. So in here you can see on our front we have our cooling fan, which will be used during cooling and also humidification. And then on the right side you can see that we have one sensor here, which we put the okay. So and then here is our layout for our AutoCAD drawing. We have our base, which are on the bottom. We have our front view, And lastly, our side view. And lastly, last but not least, is our isometric view. So this is our layout for our drawing on AutoCAD. So just now I mentioned about the heater that we put in our box for this experiment. So this is the dimension, which the length is 40 centimeter and the width is 60 centimeter.
Hello and good morning, everybody. Today I will be explaining the part of each procedure in the experiment that we have conducted here in week 3. Now, without further ado, the first procedure that we did was heating. Now, in this procedure, all we had to do was keep the box closed, and before we start anything, we record the initial temperature and also the humidity. After that, we switch on the heater and set a timer. Every 3 minutes, we record the temperature and also the humidity of the inside of the box. And it keeps going every 3 minutes, and then 6, and then 9, and then 12, and then 15. So that's five different readings. And after that, we switch off the heater and we collect all the data. Okay, so the next step of this experiment would be cooling. And to cool this box, we have to, well, of course, turn off the heater from the previous experiment. We turn the heater off and make sure that the box is closed. And after the box is closed, we, as usual, have to record the readings of the temperature and the humidity. And after that, we turn on the fan that's located at the side of the box. And that's when the cooling process starts. After every 3 minutes, the process is still the same. So every 3 minutes, we stop and record the value of the temperature and also the humidity. And we keep going 3 minutes and do it over and over 5 different times and record everything. And at the end, we turn off the fan and take the final readings. All right, so for the final 2 steps, we have humidifying and dehumidifying. Now, the humidifying process is very much self-explanatory. It's that we have to open the box really quick and spray water for 10 to 20 seconds and then leaving it closed and for 15 minutes. And every 3 minutes, we will collect the data of the temperature and also the humidity. And lastly, we have dehumidifying, which is the opposite of humidifying. We just have to, steps are easy and simple. We close the lid and turn the cooling fan, and after that, as usual, we have to record all the readings, including the temperature and also the humidity. And that goes on for every 3 minutes until we reach 13 minutes.
Let's move on to our next part, which is result and discussion. Firstly, for our heating part, if you look at the temperature, it shows that it increases steadily from 31.8 to 38.8 degrees Celsius over the course of 15 minutes. So this shows that the heat is being added continuously to the air. In this case, in our experiment, is the heating plate. So the gradual rise indicates the controlled heating rather than sudden heat input. So this is for temperature. For humidity, we can see that our relative humidity initially increased from 55.7% to 62.7% at 3 minutes. Then it decreased to 40.7%. So although there is no moisture is being removed, the heating the air increase the moisture holding capacity. This resulting in the relative humidity decrease even if the actual moisture content remains nearly constant. So in conclusion, heating raises the air temperature and generally lower the relative humidity due to increased air capacity to hold water vapor. We move on to our cooling part. For our temperature data, we can see that the temperature dropped sharply from 38.8 degrees Celsius to 33.6 degrees Celsius in the first 3 minutes. Then it decreases slowly to 30.7 degrees Celsius by 15 minutes. So this indicates the effective heat removal with cooling rate slowing as the air approaches room temperature. So for the relative humidity, we can see that it rises from 40.7% to 54.3%. So this means that the cooling reduces the air capacity to hold moisture, causing the relative humidity to increase. This may approach condensation condition if cooling continues further. So in conclusion, cooling lowers temperature and increase relative humidity due to reduced moisture holding capacity of air. So next we move on to our next section, which is humidifying part for our experiment. So looking at our temperature data, we can see that our temperature is slightly increasing from 29.2 degrees Celsius to 30.6 degrees Celsius. So this small rise suggests that moisture additions adds a minor amount of heat. In this case, it can be a latent heat of vaporizing. So for our humidity data, so the humidity data decreased from 64.3% to 58.3%. So why does the relative humidity decreases? Because since our temperature is increasing due to the additional heat of vaporization, so if you look at the cyclomatic charts, so what will happen is our initial point, as our temperature is increasing, so the point will shift to the right. So when that happens, so we can see that as we conduct the experiment more and more, so the point shift to the right, so it leads to a decreasing in relative humidity. So yeah, that is for result and discussion. So lastly, we're going to be looking at the last part of our experiment, which is the dehumidifying process. So looking for our temperature data, so we can see that our temperature is actually remains constant, which is between 30.5 degrees Celsius to 30.7 degrees Celsius. This indicates that heat removal is minimal and well balanced during the moisture removal. So for the humidity data, we can see that our humidity decreases from 58.3 degrees Celsius to 55.7 degrees Celsius. This actually means that the moisture content is actually being removed from the air. So the stable temperature suggests the controlled dehumidifying without significant cooling. So in conclusion, dehumidification mainly reduce humidity while maintaining a nearly constant temperature. Okay, so that's all for result and discussion processes for our experiment.
So in conclusion, we can conclude that this experiment is successfully demonstrated the fundamental principle of thermal and also humidity dynamics within an enclosed system, which is in the box. And in summary, we can say that we observe the trends of the temperature and relative humidity for during heating, cooling, humidification. Dehumidification is aligned with the core of psychometric principle, which we can confirm the relationship between temperature and also moisture content. And lastly, for the recommendation, we recommend to have I think we can better seal the insulator box, which we can minimize the heat exchange in the laboratory environment, which we can have a better accurate and also constant results. And lastly, we recommend that not to open the box when we don't need it, because our group accidentally opened the box where it doesn't require us to open it. So our reading like slightly not so accurate from our desired readings. So we recommend not to do the same mistake as us. That's all from me.